Everybody, we working on adding fractions. Okay, but we're going to add our fractions using our fraction tiles. What do you notice about the fraction tiles? I got 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/8, 1/10, and 1/12. What do you notice about these tiles?
They got different denominators.
Different denominators.
It goes from big to small.
It goes from large, like big tiles, to smaller tiles.
Different shapes.
Different shapes. Anything else? I want to go back to what you said. She said they go from large to small. Why do you all think that they're going from like a bigger tile to a smaller tile?
The value, say like the value.
Caleb Coleman, report to the office for checkout. Caleb Coleman, report to the
Say it
office for
again,
checkout.
To equal 1,
What you mean to equal 1?
because like you got 12 or 1/12, like, it don't equal 1. So
1/12 equal 1.
12 equal 1.
12 12 equal 1. That is right. 12 12 does equal 1. What else?
Okay, so you said why do you go from big to small?
Mm.
Okay, so say you got like a piece of something.
Mm.
Okay, so if you gotta cut 12 slices out of that piece, it's gonna have to be very small.
Okay, good. I like that. I like how she used that example. She said if I have a piece, because 1 represents a whole, so 1 could be a whole piece, a whole cake, a whole pie. So she said we had a whole pizza and we cut it up into 12 slices. Those slices are gonna be small. So what if I had a whole pizza and I cut it up into 2 pieces or 2 parts? What do I know about the 2 parts?
They're gonna be kind of big.
They're gonna be big, right? Because this person getting half of the pizza, this person getting the other half. So that's important that we understand our tiles. So as they go, they get small. It's one more thing I want y'all to tell me about your tiles. What do you notice about the numbers that's on the tiles? Anybody notice anything? I heard somebody say the denominators are different, but it's something else special about these tiles. Say it again.
I was gonna say it's only one whole.
It's one whole, right? So is this a fraction right here?
No.
No, that's one whole, right? So what type of number is 1? It's a whole number, right? What do we know about these other numbers that are on these tiles? What type of numbers are those? Proper. Proper what? It's one more type of fraction. And they are all proper fractions. What is it called? Okay, well, let me see somebody else. What other type of fraction? These are called all proper fractions. What makes these proper fractions?
Because
What makes something a proper fraction?
they less than
They are less than 1. What else?
if the numerator is 1.
The numerator is not necessarily the numerator. It doesn't have to be 1. What else?
The numerator is smaller than the denominator.
The numerator is smaller than the denominator. It's also called a unit fraction. Okay, that's fine, y'all. That's okay. These are also unit fractions because all the denominators are 1. So they are also called unit fractions. And they're also proper fraction, that's 1 whole. Okay, so we're going to look at the problem 1/2 plus 1/4. And we're going to model those with our tile. So I want to first start off with my whole piece. Because I want to see if 1/2 plus 1/4 is going to be larger or smaller than 1. So without building 1/2 plus 1/4, if I look at my 1/2 tile and my 1/4 tile, if you visually put those tiles together, are those tiles going to be larger than 1 or less than 1?
Less.
Okay, you all both say less than, everybody say less than 1. So let's build that. So I got 1/2 plus 1/4. So it is less than 1. So that lets me know what type of answer am I going to have. It's going to be a proper fraction because it's less than 1. All proper fractions are less than 1. So go ahead and build this with your fraction tile. Your 1 should be on top, and your 1/2 plus your 1/4 is gonna be on the bottom. Okay, so our goal, this is the goal. The goal is to find the same fraction pieces that you can line up under that 1/2 plus that 1/4. And that's going to be our answer. You're going to use the same fraction tile pieces. So I'm going to kind of give y'all a little template. So you're going to see what fraction pieces can fit on that third row. But they're going to be the same fraction pieces. So you all go ahead and work together and talk to each other and see which fraction pieces you need that's going to line up under that.
We can try 8. 8. Yeah, we can.
It's for me. This is just for yeah.
Okay, so I see everybody has their answer. Okay, so I see you all put ace under there. Okay, how many 1/8 pieces did you put under there?
6.
You put 6, so we're going to add 6 1/8 pieces under there. And the goal is it needs to fit perfectly and line up perfectly with that 1/2 plus that 1/4. So do those 6 eighths line up perfectly with that 1/2 plus that 1/4? No. Okay, it looks like it does. So if I trace that, that lines up perfect. Okay, so remember I told you my problem was 1/2 plus 1/4, right?
No.
And you all said it equals to what answer?
6.
6 what?
8.
Eighths. Now, our problem says add, right? So what did they do? Did they add straight across to get that 6/8?
No.
How do I know that they did not add straight across to get that 6/8 as an answer?
Because 1 plus 1 is 6.
1 plus 1 is 6.
I mean, 1 plus 1 is 2.
Okay.
And 2 plus 4, that is 6.
Okay. 1 plus 1 is 2, right? And then 2 plus 4 is 6. But these are not the same. So what we need to do is figure out how they got that 6/8 because they did not add straight across. So that is something I want to stress. When you're adding fractions, you do not add straight across. That is what people do when they do not know how to add fractions. They resort to adding straight across. They go to, okay, let me just add this straight across to get the answer that's wrong. So don't ever add straight across. That's not going to give you the answer. Now, what I want to do is I want to look at my time. I want to go back to my picture here. So I want to outline, I want to come up with an equivalent fraction. Let's talk about that word equivalent. If I got $1, what's another way I can get $1 other than one whole dollar bill?
256.
I can get 2 50-cent pieces. What else can I do to get $1?
4.25 cents.
4.25 cents. For what? What's another word for 25 cents? What's that called?
4 quarters.
4 quarters. What else? What else can I do to make $1? A paper dollar bill, and I can make it. I want to make $1 in another way. 100 pennies. Okay, now, so equivalent means that you're using something different, but it's gonna be the same answer, or gonna be the same thing. They're equal. So equivalent it just means equal. So I want to find an equivalent fraction to 1/2. So I want to outline my 1/2, and I want to outline these eighths that fall up under that 1/2. How many eighths did I use to make 1/2? 4. So 1/2 is equivalent to 4/8. And then I want to outline my 1/4 and those 8s under it. So how many 8s made that 1/4? Two. So that's 2 8s. So 2 8s is equivalent, is the same as 1/4. So now that answer is still gonna be 6 8s. Now, looking at this part right here, what did they do to get from here to there? What did they do to this part to get 6 8s? What did they do?
Add the numerators.
They added the numerator. Okay, I see that because I see. Cause how did they add them?
They
What?
added 4 plus 2, and that's 6.
Okay, 4 plus 2 is 6. And what else they did?
And then they kept the denominator.
And they kept the denominator. We got 8, 8, and 8. They still did not add straight across. How do I know they still did not add straight across?
Because 8 plus 8 is 16.
8 plus 8 is 16. So I know they didn't add straight across. So going back to my point, I'm stressing this. We do not add fractions straight across, and nor do we subtract them when we get to subtraction. But we don't add fractions straight across. They only add the numerators and they kept the denominator. So your goal when you add fractions, you're trying to come up with a common denominator. If you get a common denominator, you can add the numerators. Now in 4th grade, this is what you all learn. You learn how to add fractions with like denominators. But in 5th grade, you learn how to add fractions with different denominators or unlike denominators. Let's look at another example. So let's look at the problem 3/5 plus 1/2. So 3/5 plus 1/2. In your mind, this is what I want you to think about. We're going to visualize this. 3/5. So this is our 1/5 piece, right? How many fifths do I need to make 3/5? I need 3 of them. How many halves do I need to make 1/2? 1. Okay. Now, if I make this model right here, do y'all think that this is going to be larger or smaller than 1? What do you all think?
Smaller.
Somebody, you said smaller? Smaller? What you think? You think gonna be smaller? You gonna try larger? Okay, let's see. So I heard 3 of you all say it's gonna be smaller. So let's try it out and see. So we adding 3/5. So I got 1, 2, 3. Everybody need to just be looking. Plus 1/2. What happened when I put this 1/2 up here? What's happening? It's too large. It disappeared, right? So that lets me know that 3/5 plus 1/2 is gonna be what?
Larger than 1.
Larger than 1. So I want to change up my units. I need 2 of these up here because I need room. So I'm gonna put it back up here. 3/5, 1, 2, 3 plus 1/2. What do you notice? It's larger than 1. Everybody see that? Model that. Go ahead and model that. 3/5 plus 1/2. And I want you to come up with what can fit. We're using the same tile, equal parts, to line up under my problem.
I want to try 10.
Try what you think.
Okay.
And if you don't have enough pieces, you got to borrow a piece from somebody, borrow from your neighbor. Okay, so tell me, I see you all trying 1/10. Why are you all trying 1/10 or trying tenths?
Because I already see that 1, 2, 3, 4, 5, 6. 6 tenths are equal 3/5.
Okay.
So, and I just need some more tenths to see is it gonna be equal.
It's gonna- Okay. And you know you got something different. You got 12. So tell me why you trying 12s.
Because these are like smaller, so it's all gonna fit because these are smaller.
You said because they small, they gonna fit. Okay, let's go ahead and try it. Okay, yeah, everybody got good logic. Let's try it out and just see what's gonna work. You gotta open your 10. Yeah.
Okay.
Okay. Keep building yours. Let's go ahead and keep building it. Okay, now I want everybody to look at each other's model. Okay, now all of you three got one. Y'all use 10s, you use 12. Somebody right here tell me what you notice about yours.
Mine's fit perfect.
Okay, you say yours fit perfectly. What you notice?
Mine a little too short.
It's just a little bit too short, right?
No.
And you can see it, right? So let's try the 10s. Because we see here just a little bit too short, right?
Yeah.
So let's try these 10s. How many 10s did you all put up here? How many 10s you all got? Say 11. Now, we know that this answer going to be bigger than one whole. So is 11 10s bigger than one?
Yes.
Well, how do we know 11 10s is bigger than one?
Because 11, the numerator is bigger than the numerator.
And what does that mean?
I mean, it's an improper fraction.
It's an improper fraction. And all improper fractions are what?
Larger than 1.
Larger than 1. Good. Okay, so let's work on our problem. So our problem was 3/5 plus 1/2, right? And we said the answer was 11 tenths. So let's test it out. Did we add straight across to get our answer? Okay, how do we know that?
Because 3 plus 1 is 4.
Okay,
Not 11.
right. 3 plus 1 is 4, not 11. And then, so to be honest, if we see that one of them is wrong, do I need to test the bottom number for real? My denominator, I really don't. But if I want to test it, 5 plus 2 is 7. That's not 10. So you never add straight across. I want to stress that. You never add straight across when you add fractions. Okay, so now we need to come up with some equivalent fractions to see how they got this answer. Come on.
So you can do 6 tenths.
Okay, show me that on there. Show me that.
Because 6 tenths and 3/4 is
3/5?
3/5
Okay.
are equal to each other.
Okay, I see that. So right here, if we do what he said 6 of these tenths. So it's 1, 2, 3, 4, 5, 6. So that's 6 tenths. Plus, okay. Now, what is equivalent to 1/2? How many tenths is equivalent to 1/2? So we see 5. Okay, let's see. So let's count that.
1, 2, 3, 4, 5.
So that's 5 tenths. Okay. And that answer is supposed to be 11 tenths. Now, do we see how they got 11 tenths once we make these equivalent fractions? Okay, how do we see that? You hear from somebody else? Come on.
Because
How they get that 11 tenths? Come on.
the 11 tenths.
Mm-hmm.
Because 6 plus, they added the top number. Because 6 plus 5 is 11.
Okay.
Then they kept the bottom number, so it's going to equal to 11 tenths.
That's right. They added my top number. What's my top number called? And then what's my bottom number called? And they got 11 tenths. Very good. Now, next time we're going to talk about how can we change this improper fraction to a mixed number. But that is very good. Okay, very good. Now go back to doing your work.